This is worksheet 9.4. We are simplifying rational expressions. Let's do it. So, for number one, I have this expression or polynomial divided by that one, but let's get it in factored form. So I'd be looking for numbers that multiply to 30 and add to 13, which would be 3 and 10. So that means that the top factors to n plus 3 times n plus 2. N plus 10. And that's being divided by n plus 10. So we do have a common factor here. The top has a factor of n plus 10 and the bottom has a factor of n plus 10. So what's left? Just n plus 3. You don't need to put that over 1. You don't have to put a fraction bar there, but you can. It's not wrong. This is the best answer though. Most simplified. Number 2, we got to factor this. So you're going to look for numbers that multiply to negative 20. How did I get that? When there's a value, you have to multiply it with the end value or the c value. So 5 times negative 4 is negative 20. Looking for numbers that add to 19. Because we're trying to multiply to a negative 20, one has to be positive and one has to be negative. So there we are. Now off to the side, I'm going to put this in factored form. So we have n plus 20 times n minus 1. And now we need to divide it by the leading coefficient, the a value. So this simplifies to n plus 4. And remember, if we can't simplify or after we simplify the fraction, which I try to simplify this one and I can't, if we have a denominator, it slides in front of the variable. So it's 5n minus 1. By the way, if you want to finish that somewhere else, Logan, you can. Okay. Oop, that's 5n minus 1 divided by oops, I was using n's, I guess, from the last problem. These are supposed to be x's. I'm going to switch this to an n plus 4 on the bottom, so I'm using the same variable, although they should all be x's. So we have a common factor. N plus 4 is a factor on the top and a factor on the bottom, so we get 5n minus 1, final answer, or 5x minus 1. Alrighty, rolling along. Number 3. These are the easy diamond problems, so numbers that multiply to 12 and add to 8. 6 and 2, right? So n plus 6 times n plus 2 divided by numbers that multiply to negative 14 and add to negative 5. So it's a negative 14, so that means one number needs to be positive, one number needs to be negative. Let's do negative 7 and positive 2. And we have a common factor here with our n plus 2's. So let's cancel that out. So here is our final answer. And yes, you should rewrite it. N plus 6 divided by n minus 7, final answer. Alrighty, number 4. Number 4, when you make your diamond on top, when we try to factor that trinomial, there is a GCF, folks. I can take 2 out of each of these. So on the top, I can be thinking of that as 2 times x squared minus 2x plus 1. When I factored the 2 out, I divided all the values by 2. And so now my diamond is what multiplies to positive 1 and adds to negative 2. And I'm, again, doing the easy method because now my coefficient of x squared is a 1. So negative 1 and negative 1 work here. So I have 2, that's my GCF, x minus 1 times x minus 1. Now on the bottom, that's not a 3-term polynomial. So I always should be trying to take out a GCF anyway. I can factor out a 2. And then I'm left with x squared minus 1. And that's going to be a difference of squares. Or you could make a diamond that says, all right, what multiplies to negative 1 and adds to 0. Because notice there is there's a missing x term. There are no x's there. There's 0 x's. So that's what you get. And positive 1 and negative 1 work there. So we can factor this. You good? Awesome. Do you want to say hi?
No.
All right. Do you want to say no? See what I did there? See, a nice job on that. So that is completely factored, folks. And now take a look at your factors. Is there anything that you can cancel out? You bet. An x minus 1 with 1x minus 1. You can only cancel out one of the x minus 1s on top. And then anything else you can cancel out? Yes, a z2. So we get x minus 1 divided by x plus 1. Boom. Like that. Number 5. So these are already kind of factored. And what I like to, when you multiply fractions, you just multiply straight across. So honestly, folks, I'm just going to make that fraction bar into 1 and realize that this stuff is getting multiplied together. Now this I should probably put in parentheses now that it's all for 1. So it's m plus 2 times all of this. I could put the 5 in parentheses too if I wanted to, but there's only one term there, so it doesn't make sense to, you don't have to parenthesize it. So now everything's completely factored. So now I can start cross-canceling the 5 and the 5, and the m minus 5 and m minus 5. So on top that leaves me with 4, and on the bottom it leaves me with m plus 2. There we are. That's it. Here, again, we are multiplying. So this is not a division sign. Maybe I should make different colors. So on top I have the stuff on the left of the red dot times the stuff on the right of the red dot. On the bottom, the same thing. Since there's 2 terms to the left here, this all is getting multiplied with everything over there. So now I can start cross-canceling. 3 and 3, n plus 1 and n plus 1, n plus 4 with n plus 4. Ooh, that was fun. All I have is 3n left. Number 7, all right, so now I need to start factoring things like this term, this factor up on top of this polynomial needs to get factored. So I'd be looking for numbers that multiply to negative 20 and add to 1 because there's a coefficient of a 1 there. So it'd be a positive 5 and negative 4. So maybe I'll just rewrite that without trying to move it. I'll rewrite that right there. Maybe since that's all I have to factor. If there was a lot you had to factor, you probably should rewrite stuff so it's easier to see. So I have an n plus 6 and an n plus 6, and I have an n plus 5 and an n plus 5 for a factor, so that means I'm just left with n minus 4. That is the answer. Here, what kind of factoring method should I use for this polynomial? I'm going to take out a GCF if I can. So I'm going to rewrite this. I'm going to have 7 times, I can factor a 10m out, and then I'd be left with m plus 5. And on the bottom, I can factor a 10m out of this one as well. So 10m, that leaves me with m minus 6. And then don't forget, I have this m plus 5 on the bottom as well. So what can cancel out? What are common factors on the top and the bottom? 10m and 10m, and m plus 5 and m plus 5. So my final answer is 7 divided by m minus 6, like that. Alrighty, last couple. Oh boy, what are we doing here? We're not multiplying fractions together, we're dividing them. So when I divide fractions, I need to change that into multiplying by the reciprocal. So I'm going to rewrite this. These you should rewrite, although this one's easy enough to change, but I'm going to practice what I preach. So n plus 5 times n plus 4 divided by 4n. You keep the first fraction as it is. Now you switch this to multiplication. I'm going to use a big boy, high school, big girl multiplication dot. But then we have to switch or flip a reciprocal. That's the actual word for it. Take the denominator, turn it into the numerator. Take the numerator, turn it into the denominator. So they flip sides of the fraction bar. And now because we're multiplying this together, folks, we make this into one fraction. That 4 is getting multiplied with everything over here, and this 4n is getting multiplied with everything over there. So now that everything's completely factored, I can start cross-reducing. So it looks like I'm left with n plus 5 over 4n. Next one. You know what? Maybe before I flip it, maybe I'll take out a 3x from the bottom. So now I keep the first fraction as it is. So I'm going to have 1 over x minus 3. I'm going to put that in parentheses since I'm going to be multiplying that, changing the division to multiplication, and flip the bottom to the top and the top to the bottom. So on the top, we're now going to have 3x times x minus 1. And on the bottom, we're going to have the x minus 1. And now the top is getting multiplied with the bottom, so it's all, retract that. I turned this into multiplication, and we multiply straight across. So the top is just getting multiplied with the top, so it's 1 times 3x times the quantity x minus 1. And the bottom, it's the bottom times the bottom, so x minus 3 times the quantity x minus 1. There we are. So let's reduce, boom, boom. You get the final answer of 3x over x minus 3. 2 left. This one's not factored yet. That'd be m minus 1 times m plus 3. That's in place of that. So now let's keep the first fraction as it is. Let me change colors from what I had just factored. So my first fraction is m plus 3. Is that any better? Divided by m minus 1 times m plus 3. That's keeping the first fraction as it is, although I did factor the first fraction. Keep. Now switch the division to multiplication, and now flip or reciprocal the second fraction. So the m plus 3 goes on top, the 1 goes on the bottom. Now these fractions are getting multiplied together, so just multiply the top with the top, but give them a hug please because they're more than one term in the factor, and the bottom goes with the bottom. So now we cross reduce. One of the m plus 3's on top, doesn't matter which one, gets canceled with the one on the m plus 3 on the bottom. So we have m plus 3 divided by m minus 1. There we are. Last one. I kind of like factoring things first. So I'm going to give myself some more space on the top because the top's where I need to do some work. So this is the same as 8 times 2x plus 1, right? And if you don't like the factoring you did, go back and multiply it in. Yeah, you get what you started with. And here we're going to be doing the AC method. So numbers that multiply to 6 and add to 7. So that's going to be, oh, yeah, that's right. So 6 and 1. So we would get x plus 6 times x plus 1. But we need to divide those because it's the AC method, or slide and divide. Slide and divide we've been calling it. We have to divide it by our leading coefficient, which is 2. So we get x plus 3 times 2x plus 1. So that goes on, well, that would go on what is the top right now. But see what's going to happen here, right? So let's rewrite the fraction. We're going to keep the first fraction as it is. We're going to switch the division to multiplication and flip the top and the bottom. So the x minus 2 actually goes on top, and this factored trinomial right here is now going to go on the bottom. So we have x plus 3 times 2x plus 1 on the bottom. And so now we can cross reduce, boom, boom. The 8's also go right. See the 8's out in front? So we get x minus 2 times x plus 3. Final answer. Beautiful.